so for this, we're going to fill in if. So if we know these two things, if we know that DE is parallel to AC, then we can set up a proportion a specific way. So there are two sides to this. There's this side over here, and then there's this side over here, which if you look at all the pictures, all the numbers are on the sides. Stacey, where are you going? Where are you going? I'm just going to say to class. Okay. 9:21. Josh, are you going to the same place or no? Did you finish? Okay. Josh. No class. 2:15. Yep. Thanks. There you go.
Thank you.
Have a good weekend. Okay, so we have two sides. We have this side and we have this side over here. So the way we're going to set up our proportion, if we know that these two lines are parallel, which is what the little arrows mean, is that we can say that DA divided by, so DA is a length, divided by DB. So on the same side, so you're basically taking one of the pieces and dividing by the same piece on the same side is equal to the other side of the triangle. Since I used DA, this is the catch. If I use DA for the numerator, the top of the fraction, then on the other side, I have to use EC for the top of the other fraction. So I'm going to say EC is over here. Divided by the bottom, we said is DB, which is this little piece. So that's going to be congruent or similar to BE over here. So today it's a little bit different because we're talking about the same side. We're going to do piece on the same side divided by the same side, and then piece on the same side divided by the same side. Okay, so you're doing like individual pieces. On the converse, we did converses and contrapositives and all that, inverse and all that jazz. The converse literally means the opposite. So it's basically using common sense. If I know that these are parallel, then I can set up a proportion. The opposite of that, the converse of it, would be literally saying the same thing, but backwards. If DA over DB is equal to EC over BE, so the same exact proportion, then I know that the two lines are parallel to each other. So it's kind of like using common sense. If I know one thing then about something, then I can go the opposite and say the same thing, just backwards. So we're going to do number 2. We're going to set up 2 on the front. We're going to set up 2 on the back. This is not terrible. It's not bad. It's cross multiplication again. So if I'm looking at number 2, I'm going to do side equals the side. Okay, so it doesn't matter which side I start with. So I'm just going to pick this one right here. I have 2 fractions. It doesn't matter if I use X or 18 first, technically. Yeah, go ahead. Oh, Isaiah, you took the bathroom pass. It doesn't matter if X is on top or if 18 is on top. It literally doesn't matter. But because I chose X to be on top first, what should be on top on the other fraction? Should it be 56 or should it be 21? 56. Because X is in this part, so 56 is in this part. So it's because X is on the top, then 56 has to be on the top on the other one. Notice that 18 was at the bottom, so now I'm going to use 21 at the bottom. And then it's the same process. I'm going to cross multiply, making my cute little butterfly. Isaiah, put your phone away. Take your test. Okay, so 21 times X is just 21X. And then I'm cross multiplying the other way as well. I'm going to do 56 times 18. So 21 times X is 21X. 56 times 18. Isaiah, put your phone away. Take your test. And then I'm going to divide by 21 on both sides. So X equals 48. What are you doing? Okay, so going right underneath that, we're gonna do the same thing for number 4. So number 4, same thing. It looks a little different because I have that extra line. So I'm just gonna start with this piece. It doesn't matter. It doesn't matter how the first fraction is set up. Literally does not matter. This time I'm gonna say 7 over x because you can say it the opposite way. It literally does not matter. So if I do 7 over x, what would have to be the fraction on the other side? What would have to go on top? 6. So 6 would have to go first. And then what would this piece be if this whole length is 27? 21. So this piece is going to be 21. And then I'm going to cross multiply, same process that I did for the last problem. So I'm doing 7 times 21. And then I'm going to cross multiply the opposite way, 6 times x. Seven times 21 is 147. 6 times x is 6x. And then I'm just going to divide by 6. So it doesn't matter how the first fraction is written, but it does determine how the second fraction needs to be written. So you will get decimals on, I think, 3 of these problems. Pretty sure there's 3 decimals. So that's one of them. What's up? Did you have a question? Are you stretching? Okay. Let's go to the back. It's the same concept, but it looks a whole lot crazier. Okay, so on the back, they look a lot crazier, but it's literally the same idea. On the front, there was 2 parallel lines, which was creating the triangle. On the back, if you notice, there is 3 arrows. So these 3 lines are parallel to each other. So I'm going to say AB, if AB is parallel to CD, which is also parallel to EF, then I can set up the same type of proportion. I'm basically going to do one side divided by itself is equal to the other side divided by itself. How I write the first fraction has to determine how I write the second fraction. So if I say, let's just say AC, if I say AC is going to be divided by the same side, which is, I'll say CE, I have an equal sign in the middle. Because I put AC in the numerator, what side has to go in the numerator on the other fraction? BD. And then because I used CE in the denominator, that means DF is going to be in the denominator on the other fraction. So it's the same concept. It just looks a whole lot crazier. So let's just go to let's go to number 10. So number 10, I'm going to do the same thing. I'm just going to pick one side to start, and then that's going to determine how I have to write the other fraction. So the fractions look these pictures look a little crazy. So if I jump down to number 10, I'm just going to pick this side, doesn't matter. I'm going to pick this side right here. And I'm going to say that I want 35 or 31.5 first. We're going to have to set up a proportion. Does anybody know what's going to have to go under 31.5? X, because they're on the same line. So same line, same fraction. On the other side, because I put 31.5 first, what has to go in the top on the other fraction? 28, because they're the same piece just across the way from each other. So 31 has to go at 28. And then if this whole length is 92, what's going to be this length right here across from X? 64. Because they have to add together to make a distance of 92. So I'm going to use 64. Same thing, I'm going to cross multiply, just like I've been doing for the past couple days. So I'll start with this one, 31.5 times 64. Which is 2016. And then I'm going to cross multiply the other direction. So I'm going to do 28 times x because butterfly for life. 28 times x is 28x. And then I'm going to divide. So x equals 72. Okay. Last one that I'm going to set up for you. I'm going to give you a second to try to set it up. I'm going to give you one piece of it because I want to see if you can fill out the rest of the problem. I'm going to say that I want you to use x plus 3 first, and then see if you can fill out the rest of the proportion. So take a second. If I say I want you to use x plus 3 for the numerator, try to see if you can fill in the rest of the proportion. Okay, so what's going to match what goes underneath x plus 3? Anybody know? 12, because they're on the same line. Because they're on the same line, they're going the same fraction. Now, the tricky part is because I put x plus 3 first on the top, the matching piece that goes with x plus 3 across the way on the other line is going to be what? What has to go in the numerator on the other fraction? Two x plus 2, thanks. And then 12 across the way is going to be 21. So then you would cross multiply, same process. This one, you will have to use the distributive property. So you're doing 21 times x plus 3. And then over here, you're going to have to distribute a 12. 12 times 2x plus 2. Okay. So I want you to continue working on these. If you need to work on your test from last week, I'm going to pass those out so you can work on those. I'm planning on grading them all tomorrow while I'm at district-wide training. That's our training. No, so normally I would like to do on top of them. If it's graded, it's already in the grade book. I haven't graded any other ones. But normally, I know you're like around here, usually I'm like grade them the same day you take them. But
I get this.
yes, that one's decimal. So I'm pretty sure there's 3 decimals total on this whole paper. Is there anybody else that needs to take the test? You want to? Does anybody else? I think everybody else would. I finished number 12. If you want to copy it, you can.
You can tell me if there's another step one.
Yes. So the whole, my hint to you is the whole thing needs to be.
You're gonna have them all out, just goes, oh, so I, all the actions and.
You start with her. Give me the word, please. Give me the word. Bernie, that's right. I finished it. Okay. Give me the word. It'd be fine to turn it into spin. Okay. Give me the words clear to take it. Oh, yeah, yeah. Yes, that one's the small. Let me know if you get stiff, let me know. Set up on equation. Okay, over here. So on the same side, you're gonna make an equation out of this two numbers, fraction. Doesn't matter if 12 is on top or 14 on top, doesn't matter. Well, perfect. Since you put 14 on top, what has to go on top for the other side? Yeah. X up there. And scalable. Cross multiply. That's perfect. You should have my favorite. I approve forward. But